let's talk about the differences between ETL and ELT, which is extract, transform, load, and extract, load, and transform. Right, as you can see on the screen, as we have seen till now, the usual approach which we follow to build a data warehouse is ETL, which is extract, transformation, and load, which is kind of more traditional and widely accepted approach even today, right? So the data is extracted from different kinds of data sources, and it is then transformed using a series of transformation routines. When we say series of transformation routines, it can be your business validations or data quality checks or any of your data scrubbing, cleansing, or any of the validations whichever are applicable for your source data to be stored in your data warehouse. Right? Now, data quality and integration checking is performed as part of the transformation process, and any corrective actions which are required to make the data more better and which are used to build a data warehouse in the whole process, right? So transformations and integration checking are performed in the data staging area. As you can see in the staging database, these are performed in the staging area. Now finally, once the data is in the target format, then it is loaded into the data warehouse from where the BI analytics come into picture. Right now, this process is often designed from the end backwards, meaning you have a particular target format which you want your data to be in the data warehouse. Now, in that, the required output is designed first, right? Once you know that a particular attribute should be in XYZ format, you're trying to transform the data in whichever format it comes from your source into XYZ format, right? So in addition to that, the output design must incorporate all facts and dimensions required to present both the aggregation levels required for the reporting or BI solutions and any possible future requirements, right? That's the whole purpose of a data warehouse, right? So the business rules that define how aggregations are achieved and the relationship between the various entities in both the sources are targeted, are designed, and therefore coded into the routines that implement the ETL process. Right now, this approach leads to a tight dependency in the routines at each stage of the process. Now, everything is business driven, everything is logic driven. So if you have a requirement to have your aggregation at the data warehouse level, that has to be done only at the transform level, right? Now, in spite of the fact that there are effectively 3 stages, the design is often characterized as a monolithical process since the target is predefined and clear. Right now you have ETL, which are the 3 different stages. But before you start any of these IT implementation, you come to a conclusion with your business during the data modeling phase on what is the format of data which you're expecting, right? And what is the target state? Now, based on the target state, whatever is your source state, you're converting that using the transform method, right? So if you go with this approach, what are the strengths? The strength is the development time, right? Designing from the output backwards, because now you know what should be your target state in your data warehouse. Once you know what should be your target state, you go back to your extraction state and see what is the format. Let's assume it's ABC here. You transform it with some business logic and convert that into XYZ, right? So this potentially reduces the time for your overall discussion about what it should be, multiple trial and errors, because you've decided on the data format, isn't it? Right? It means it is reducing your development time. Now, tools availability. Now, you know, there are multiple tools, and this is the best process which is being used right now. The best tools within the market for ETL are Informatica, DataStage, right? Those are pretty strong in the market now, even with big data coming into picture and ELT also in picture with quite some time. Informatica and DataStage are still leading the ETL or ELT market, right? What are the weaknesses? Flexibility. Now, targeting only relevant data for output means that any future requirements that may need data that was not included in the original design will need to be added to the ETL implementation going forward, which means you're making a change. And any change is costly. It needs efforts, manual efforts, and sometimes infrastructure resources also has to be enhanced, right? Now, due to this tight dependency between the transformations developed, this often leads to a need for fundamental redesign and development, right? As a result of this, the time and costs are involved, which is nothing but the implementation of the overall structure again, right? Now, if you look at that perspective, you might also go with the hardware changes, right? Most of the third-party tools utilize their own engine to implement the ETL process. Now, regardless of the size of the solution, this can force you to invest in an additional hardware to implement the tool's ETL engine. For example, let's say if you want to get a new feature to be available on your project, and that feature is available only with an upgrade from version X to version Y, and that new version is not supporting your existing hardware, then you have to invest on your infrastructure as well, right? And if it is a new feature itself, then obviously your existing team should be ready to learn the new feature and then implement it, right? That's about the extraction, transformation, and load. We'll talk about the differences again at the end. Now let's talk about the other one, which is ELT, which is extract, load, and transform. Now, while this approach to the implementation of a warehouse appears on the surface to be similar to what we've done, which is ETL, except for this shuffling of transform and load at the end, it differs in a number of significant ways, right? Now, as you can see here, your source data here is being loaded into the warehouse directly. Once it is loaded, we are doing the transformation within the data warehouse. Right, so the data is extracted from different sources into the staging database, which is maintaining the raw content as is without as many changes, right? The direct data connectivity. Now, while the data is in the staging area, the integrity and business rules checks can be applied and relevant corrections can be made, but it is not mandatory. Because in your design, if you think as you're loading it into data warehouse anyways, why do we need a staging database? You can remove it from your architecture completely, but that purely depends on what kind of structure you want to see in your data warehouse and your business requirements, right? Now the source data is then loaded into the data warehouse. In effect, this provides a validated and cleaned offline copy of the source data in the data warehouse. Now, once in the warehouse, transformations are performed to reshape the data into the target output format. Now, the extract and load process can be isolated from the transformation process, which leads to a number of different benefits. Now, isolating the load process from the transformation process removes an inherent dependency between these stages. Right. In addition to including the data accuracy for the transformations, the extract and load process can include elements of data that may be required in the future. Now, the load process could take the entire source and load it into the warehouse. Now, separating the process enables the project to be broken down into smaller chunks, thus making it more predictable and manageable. Performing the data integration checks at the staging area enables further stage in the process to be isolated and dealt with at the most appropriate point in the process. Now, this approach also helps to ensure that only cleansed and checked data is loaded into the warehouse for transformation. So if you get 10 million records, you won't dump all 10 million records into your data warehouse. You first verify what should be filtered out, what should be your verifications, and the properly validated data is going into your data warehouse. Now, again, if you look at it, we are doing a transform at this phase, depending on how you want to do that, right? So you can call this as ETLT, like extract, transformation, load, and then transform again, right? Now, that's also one of the feasibility. And again, these are just technology wise or technically and implementation perspective, both are possible. The ETL, ELT and ETLT, all these are possible. But what is more appropriate and what is the reason you're choosing a particular format is what you have to decide based on what is the desired output. And the only thing which you have to remember is the future state, like what will be the relevant changes. Now, obviously, nobody can guess or give you that, okay, in the next 4 years, this will be the state, so let's design accordingly. Maybe you'll get that from business, but that is bound to change, right? I mean, that can change. It's always, I mean, most of the plans which are made in a project depends on multiple factors like market situations, budgets, IT knowledge, implementation time, etc. Right? So what are the strengths if you go with ELT? Now we are minimizing the overall transformation process. For example, if there is a new format which has to be identified in the data warehouse, that can be done at the staging layer and then loaded into the data warehouse, and you can transform it at either of these places, right? And you might not have to go with additional infrastructure in this case, because even if there is a new format or new attribute or new source which is coming into the system, then you can use the existing infrastructure only to pass all this information into, right? What are the weaknesses? I mean, this is against the traditional structure of ETL, and the tools which also support ELT are limited. The famous one which is there in the market is ODI, right? So which one to choose or what to choose completely depends on what is required. It is the one which drives the business, but practically looking at it, ETL is the best choice. The tools which perform the ETL are leading the market for years now. So this is the best choice. Again, of course, you have pros and cons. Every point I made in this session now is debatable. I mean, if you have two people, which is me and you can debate about ETL and I can debate about ELT. Both has its own advantages and disadvantages. But as I've been saying, it completely depends on what is your final output, what is your best option to choose for the business requirement which the business is looking at in a cost-effective manner, right? So let's quickly look at the differences again. In ETL, data pipelines are used. However, in ELT, the data is completely loaded first to the destination server, which is your data warehouse, and then you do the transformations to the data, one record at a time, right? So based on whatever validations you have, it will do it one record at a time. It is a data set, right? It can be done at a data set for 1,000 records, 10,000 records, or 1,000,000 records. Intermediate data results are stored in the memory of the system. Now this is all stored in the database because you're already loading the content onto your data warehouse. What are the advantages? Complex transformations are possible and intermediate results in the memory makes it faster. However, for ELT, everything is stored at the SQL. So depending on your benefits and the database and the functions and the space and the RAM space which is available at the database, it can do a very large data set processing without issues. Disadvantages: larger data sets could overwhelm the memory. For example, even if you go with 36 GB RAM or even beyond that, if you're using any of the VMs or a direct server as well, and if you're processing about 20 millions of records, that could cause an issue, right? It could also overflow your RAM memory size and start using your hard disk space for your processing. Right now here everything is done at the database level, so whatever database capabilities are there, you can leverage on all of them. Updates are more efficient using set-based processing because unless you identify a set on how to do the updates, you'll not be able to do the updates, right? However, on ELT, it is still RDBMS, which will give you the more disk activity, right? So both has its own advantages and disadvantages. So it completely depends on what is it that suits best for business and their business requirement and the near future goal when it comes to the maintenance and enhancements of the overall changes. Hope it's clear on what is the difference between ETL and ELT. Thanks.